I am recording.
Hey, Miss Newman, why don't you just...
Because I'm too short of hair.
Climb up on the table.
That's actually a good place.
Don't worry, I'll spot you.
Chloe plays basketball, she can reach it.
I tried standing on a ladder, like I could not figure it out. It was not
You
easy.
use the ladder?
Dane is tall.
Right? I mean, my step stool is right there. It's too short. Look at the creep. Okay, so class.
And then like everyone else.
Class. Class.
Already? Oh.
Migrate.
So we are working on page 404. You want to do as well on this unit as possible to get the highest grade possible. It's your last one before the test. It's not a hard unit, but if you don't do the homework, you will not get the little details and you won't do as well. Okay? There is some weirdness. I don't know if we'll get to the weirdness today. But there is some weirdness in this unit. It's mostly pretty easy. We are going to do vectors. How many of you have done vectors before? Physics. Okay, that is going to be super easy for you.
I was not.
Okay, it'll be easier in my class because we don't do the hard stuff. Okay. Okay, but class, I don't want to have to raise my voice, so if you can just shush the people around you. Shut up.
Whoa! Period. Come on.
For right now. Uh-huh. I will. Okay, so this is objective 4.1.
You need added notes, maybe?
Law of Sines.
No, not that.
And this begins on page 404. Okay, I like to have the date. You do need this on here because I am not always the person who's checking off the work. I do have assistants that help me. And if you don't put the objective on there, they're probably going to write a question mark because they don't know what they're stating. Okay, because they know like what problems to look for, they know what page to look for. But if you don't label it, they're not going to figure it out. She'll come back. Okay. I like having the date because it helps keep my stuff in order. Okay? Your essential question is, how do you apply the law of sines to solve oblique triangles? Forgot the L. Oblique. Okay, so I heard what? Does anybody know what oblique means, or oblique for an oblique triangle? Anybody know what the word oblique means?
Does it have any connection to obtuse?
It might. Not necessarily. It could have all acute angles. Oblique means that there is no pattern.
Okay.
It's like scaling means all the sides are different. Oblique is even, it doesn't?
Oh, no.
No, you got a scaling, right?
Yeah.
Okay.
On all sides. It'd be like a 3, 4, 5 triangle is a scaling, but it's also right.
Yes, if there's not a right angle. Okay, so they don't have to have a right angle. They don't have to have an obtuse angle. They have to have an acute angle because all triangles have to have an acute angle. They don't have to have any side lengths the same. So right triangle trigonometry is done. We will still use trig, but not for right triangles anymore. All of these formulas can be derived from right triangle trigonometry, SOHCAHTOA. But we're not going to do that. It's too much background. You just need to know how to use the formulas to solve problems, okay? So I'm going to show you guys the formula. It's here on page 404. Okay, and the law of sines formula looks like this.
I know.
A over sine A equals B over sine B. Okay? And then in the textbook, you're going to see a third ratio. You can use any two of the ratios to solve. It looks like a run-on equation, which doesn't exist. So I could use this combination to solve for one of those variables, or that combination, or that combination. You can use any combination of two ratios. Okay. But your triangle needs to be labeled a certain way. So this is for a triangle ABC. Okay. And I'm going to show you how to label that. Okay. So my angle A is right here. This is your angle. This is your side length. This angle is the opposite angle, okay? So let me explain that. If this is angle A right here, then side A is over here. It's directly opposite. Okay? If this is side B, this is angle B. So if I say this is your angle B, then your side B is opposite. Okay, and then we have one last side, that's side C, and angle C. Okay. I always draw my pictures first. Now, if you look on the very bottom of page 4 over 4, it says the law of sines can also be written in the reciprocal form. So the reciprocal form can be really easy to use as well. And I'm going to show you guys that right now, okay? Reciprocal form looks like this. Sine A over A equals sine B over B equals sine C over C. Do you guys see what I did?
Kind of.
Oh.
I just flipped them. Okay, so this is an example. You guys can just catch up for a minute. I'm going to show you this example that I did in my period 1 to help explain the concept. Okay? We're just listening right now. You don't have to write this down. Okay. Could I say that 1/2 is equal to 2 over 4?
Yeah.
Okay. Could we also say that these two are equal to 3 over 6? Okay. Is it also true to say that 2 over 1 equals 4 over 2?
No. No.
Yes.
Yes? Yes.
No, that would make it
The
two.
fractions are different, but are the statements true?
No.
Yes.
Is 2 over 1 equal to 4 over 2?
Yes.
Is 2 over 1 equal 4 over 2? Oh, well, yeah, I thought you meant are they equal to the fractions you had before?
No.
Like, obviously,
No, just these two. These two are equal, we agree? New situation, are these two equal?
Yeah.
Okay? And so then would this also be equal? Yes. Okay, so that's what this is coming from. It looks funky, but it's the same thing. Okay, this one I used to solve for a side length. This one I used to solve for angles. You can use the top one to do everything, and that's how I've taught it in the past. Myers teaches both. And her kids like that, so I thought I would try it this year. It really doesn't matter if you always use this one. Okay? It just has like one extra step if you use that one. Okay? This one I used to solve for sides. And this one one is used to solve for angles. Okay. So I'm going to do example 1. Example 1 is on page 405. Okay. And I'm going to try to write it the same way that you'll see it on the test. Okay. And in the directions here, it says, for the triangle in the figure, find the remaining angle and sides. I believe on the test it'll say, and I can actually look this up. This is my notes from last year's. Let's see. I believe it says solve the triangle. No, it does say find the missing sides. Okay, so for triangle ABC with, and then it'll list angles and sides, it'll give you 3. Okay. It'll say solve for the missing sides and angles. And then this one, there's only one missing angle. And one missing, 2 missing sides. Okay, so my first step is always to draw it. It makes it so much easier, in my opinion. So step 1, sketch, and on the label, triangle ABC. Alright, so I'm gonna have my ABC here. Okay, I don't know angle A, so I'm gonna just put an A there, maybe this little spot blank. I don't have a side A given, so I know these are 2 things I'm actually gonna have to solve for. Okay. I do have an angle B,
Bless you.
so I'm gonna put that angle in here, 28.7 degrees. And I also have a side B. Where do I put it? I'm gonna zoom in a little bit, so that's the one that's hard to see in the back. Excellent, the side across from angle B. So that's gonna go 27.4 feet. Yep, I'm taking the exact one from the textbook. Okay, so the nice thing about using problems from the textbook in a class is that you have something to reference. So like if you fall behind or you don't know what a number is or something, you can look in the book for clarification. Okay, so angle C, I also have that one. It's 102.3 degrees. Do I have side C? Nope, so I'm gonna put a C. Then you're gonna think about the first thing that you can solve for. This situation is called an angle side. Do you know why?
Because you have two angles and then a side.
Yes. We have two angles and then one of the sides touches the angle. So it's called a side angle. You don't need to remember that. Except if you have an angle side, you're going to solve for your angle first because it's the easiest thing to do. Okay. There is an angle side, but we don't call it angle side. We call it side angle. Because it looks like a backward if you flip it.
No, oblique. Oblique.
Mr. Funk had me write that.
Did he?
Yes.
In backwards?
Yeah, because it was, he wanted it that way specifically. Because
The
angle
angle side.
Yeah, you're too
That's how he wanted us to solve it.
So this is the. Uh-oh. I was gonna write it down right now. Yeah. I was gonna write it down wrong. Okay, so this is the angle side case. Okay, it looks slightly different than the side angle case. Okay, so the first thing you want to do is solve for the missing angle, and you don't need to use any advanced math to do it. You're going to use math 2 work to do it. Anybody remember what you can do if you have two angles? Yes.
Yeah.
Step 2. I'm going to call it the interior angle sum. IAS. Use IAS to solve for
That's exactly what I'm doing.
A. And capitals mean angles, lowercase means sides. Okay, so what does IAS mean? I'm going to write that down over here. Okay? It's, and I'm going to put the word triangle. Triangle. Interior.
Bruh, I freaking on.
Angle. Sum. And it says that all of the angles in a triangle add up to be how much? 180. And you can use variations of this. In this one I'm going to solve for A. So I could say that A equals 180 minus B and minus C. You guys remember doing that? Okay, so I'm going to do that part first. I'm going to say angle A equals 180, and I'm going to subtract angle B, which is 28.7, and I'm going to subtract angle C, which is 102.3. Okay. And I believe that's 49. I just memorized it from my last class. Actually, it's in the book. It's right there. 49. Okay. I did. I remember doing it in period 1. I'll only have it memorized for you, and then I'll forget it by Wednesday.
Oh, that's rough.
Yeah, I'm 40. Everything flies out my brain.
I got 31.
Yeah, teenagers have hard time. You have so much going on in your lives.
I know. It's pretty
I
close.
added the 28 and the 102.
Yes, you could add them and then subtract the 180.
And I got 31.
You got 31.
Well, that's
49. You probably just added wrong. Because 0.7 and 0.3 is 1. So it would be 180. I would do 29 plus 102.
Yeah, wow.
Okay. Now we're going to use the law of sines twice to
Because I
solve
did 120.
for sides A and C. Okay?
Yes.
Step 3. Use the law of sines to solve for side C, and then I'm going to repeat the process to solve for side A. Okay? So, I'm going to write this down right here, my equation. I like to write what it is that I'm solving for. So I want to solve for C. So I'm gonna say C over sine. What is my angle gonna be? 102.3 equals, you're always gonna use the given pair. So, what pair? B. Yes, B is our given pair because we have both parts. So, side B is 27.4 over sine 28.7. This will be a calculator test. Yeah, you guys are gonna like this unit, I think.
Does it have the calculator?
But now I gotta learn how to use calculator, so
I don't have
Now
any.
that's
You have to learn how to use a
you'd be
calculator.
amazed how many students will go, I got this in my calculator, I must have done something wrong. I'm like, you don't know what that means. So
Just go from radians.
don't try to use, learn how to use the calculator on test day. Just make sure you try to learn it a little bit before that, okay?
I mean,
Right now, yeah.
learning everything on
Okay,
Tuesday.
so class, class, you're going to solve for C. What do you think you're gonna do to get C by itself?
Multiply the sign thing.
Yes, we're gonna multiply sine 102.3 on both
It's
sides.
the reciprocal.
You could do reciprocal,
Oh.
but you could just multiply it on both sides like this. And these two would cancel. You see what I did? And then I'm gonna get a value in my calculator. I'm gonna type all of that. Let me show you what it looks like when I type it in.
I don't.
I speak Garrett.
Hmm?
Dang it, I speak Garrett.
Do you? So you speak idiot.
Or Garrett.
That's very good. I can learn.
Well, my bad.
Remember, migraine.
Yeah, migraine guy.
Yeah, this one's good. Yeah, it's really. Okay.
Sorry.
Okay. So I get 55.74. So notice in the textbook, they're gonna take that answer and they're gonna round it. They did round it to 55.75. I usually round it to whatever placeholder is in the original. So see how this one has one number after the decimal? I'm gonna round to one number after the decimal. Okay?
I'm assuming on the test it'll tell you.
Probably. I can't remember. I think so.
I hope so.
I always accept additional placeholders. Cause I'm not too worried about that part. I probably should because you guys are gonna do state testing and, or, you know, not state testing, but ACT, SAT, all that stuff, and sometimes that precision matters. Okay, so I have this one, but now I have to repeat the process to solve for side 8. So, and I'm gonna put that right over here. So this time I wanna find A. So I go A over, I guess I could've done it down here. Should I put it down there?
Yeah.
Okay, I'll put it down there. Okay, I recommend using the given pair again because the given pair is exact, it's not a rounded solution. So I like using the given pair again. Oh, that's a 7. Okay, and again, I gotta get rid of sign 49. How do I move that over? Okay, so those will cancel, and I'll end up with A is approximately. Okay, here's something really, really nice if you use a calculator. One of mine, the nice thing about these calculators is you don't have to retype everything every time. You can go up and enter, and you can just go and change the part that's different. So the only part that's different in this one versus this one is the 102.3. So I'm gonna go in there, go over the 102.3 and replace it with the 49. You're going to want to find as many shortcuts on the calculator as possible, because you're gonna hate the calculator this unit. They use it so much. Okay, so I get 43.1. Let me put this to the side. So my final answers are that one, and that. Okay. So I'm gonna list those. It's gonna feel like a breath of fresh air after the last unit. However, oh, I forgot to write A equals. Dang it. The thing that is challenging, just remember to keep your focus. We only have a short time left together, and I am not, and most of your teachers are gonna feel this way. Most of your teachers are not gonna feel in the spirit of, oh, on the Friday before Christmas, let's do everything you can to bring your grade up.
Oh, yeah.
Like, no. Try now.
That's really different. No, I'm just
Do
kidding.
you remember the Friday before last year?
No.
You don't? I do.
Do you?
Yeah.
What did I do? Oh, I probably turned in a bunch of stuff.
I think you begged me the last week, what can I do to, and
Oh, I
turned
probably
in
did.
like the entire semester's worth of homework in one day.
Wait, no. That was the end of second semester.
Okay.
That makes it better. That makes it much better,
There
yeah.
was a kid in my English class
My
who,
bad,
the last day
though.
of school was asking Mr. Martinez the reason grade.
Yep, no, it happens to me every single year.
It's back in.
It probably happens to every single teacher every single year. Don't do that. You're gonna stress yourself out. You're gonna stress out your mom and dad, parents, whoever you live with. Okay? Try now. Most of you are here because you don't usually wait till the end. It happens more in Math 3, but as it is on the last unit, I did have some students not do a single assignment or fall behind even though I said it was hard. And guess what? It was hard. Right? I mean, you know, the people who fell behind know who they are. Okay? Do not fall behind on this. This does not have to be a hard test. This could be a very easy test. Get an easy A, that'll make up for a less than satisfactory grade on the last test. So if you got a B or you just have an A, get a really high A on this one. Like I said, last test, period 1, I haven't finished your class. Period 1 had 2 students that I think got 100%. They even got the challenges right. And they're students who just always do their work. Okay.
I'd be scared.
Yeah, if you do it all the night before, your brain will not allow you to retain the information.
My brain is magical.
My brain is.
Okay, so was that test super easy then?
Oh yeah.
Oh, it was?
I thought it was fair.
Alright, good.
Yeah, makes it like 15 targets.
Most people do not say that. Most people say,
I did
holy
like
moly, what?
33.
I mean,
What does that even mean?
I asked like 15 questions in like 20 minutes, let me know.
Huh?
All the targets.
Did you study the night before?
I did. I was.
I will tell you that I did not do as well because they did not do their homework on time. So they didn't know what questions to ask. But
We got the challenge problems that we didn't get them right. We got marked down, right?
the challenges are 1 point for attempt, 2 points for correct. So you can still get a 98% in this.
1984. That's the one. Wait, so it's not like that.
Hey, class. I was having to count all the points because you
Ready.
Class.
Ready.
I do want to do the next example with you to run through this one more time before letting you guys practice. I also want to talk about another case. Okay, so I'm going to flip mine over. Okay. We are going to start working on the computers.
No, I just can't see.
Oh, yeah.
Either spot I see the speaker or the
That's it right there. Okay, so class.
Ready.
Class.
Ready.
Class.
Ready.
The next 3 examples all deal with something called the ambiguous case. That says 23 and 27.
What's
Okay, so I'm going to talk to you guys about the ambiguous case. There are several different situations. We're not going to get through all of it today, but I will start it with you. Okay, we're going to do the easy one today, the next easiest one today, and then the harder one you're going to be probably doing next week, especially for my card students. My other students, I might be able to give a little bit of it to you today, and then I'll do a video and have Mrs. Beach for the rest of it. Okay, so here's what it looks like. It's the side-side angle case. The side-side angle case has 3 different scenarios. Side-side angle case has 3 different scenarios. We call this the ambiguous case. Does anybody know what the word ambiguous means?
Something that does not conform.
Yeah, you can't conform. There's not only one possibility. There's actually 3 possibilities that can come from this situation. You can have a situation, I'm going to show you guys the pictures in the book just because they're kind of nice. You're going to draw your triangles as if they were actually triangles. But when you have, page 406 by the way. If you have an angle, a side-side angle, watch, side-side angle, you could end up with this side being too short in relationship to that angle, and it won't touch. So it won't make a triangle, okay? So you can have a situation where they touch, easy peasy. You can have a situation where you could have this one or this one, and you can have one where they don't touch at all. So there are 3 situations. I'll explain it right now. This is called the ambiguous case. I'll explain it, don't worry.
Can't see.
Oh yeah,
We're
I'm
looking
sorry.
at the floor.
Okay, you can have a situation just like before where you have one triangle. You could have a situation where no triangle exists. And then there's the hard one, when there is a second triangle that could exist. one with an acute angle and one with an obtuse angle. And I will explain it when we talk about it. Okay, so these are 3 different cases. Okay, I'm gonna come back and add a little detail there after we do a problem or two, and that way you can see the patterns, okay? I do not know the patterns in the book, I do not have them memorized. I just know how to solve a triangle and then check it. And so that's what I do every time. But some of my most advanced students, my best, most critical thinkers, understand patterns and will figure this out. And this could definitely be you, Garrett. No, I think it will be. He tends to come up with the patterns that the rest of us don't see because he's a really good thinker.
Yeah, I'm like Socrates.
Yeah. Okay. So we're gonna do example number 3.
Socrates.
This is on page 406.
Oh.
Okay. This one is the one solution case. Hi. Let me say awesome. Love it. Where are you going? Sports Meadow, huh? So cool. I'm sure it'll be somewhere good. Okay, good. Okay, so the directions will be very, very similar. For triangle ABC with, and it says A equals 22 inches, B equals 12 inches, and angle A equals 42 degrees. Then we're going to solve for the missing angles and side. First step is the same. I'm going to sketch my triangle. I have angle A is 42 degrees. Side A is 22 inches. This is my given pair this time. Okay, because they are opposite one another. So that will be a ratio I will use. Okay, I'm also given a side B, but no angle B. And I know nothing about C. So I'm going to label the remaining vertex C and the side across from it little c. In this one, we have to solve for an angle first, and I cannot use interior angle sum. We're going to use law sums. It has to solve for angle B. Does anybody know why we're solving for angle B first? Yes, got it. We have side B, and so we need to have that, and then we could do the angle side for the rest. So good. Okay. So we're gonna solve for angle B using law of sines. Remember on the previous, on the other side, when I said there's the reciprocal version and the regular? I'm gonna use the reciprocal one this time. Do you guys know why? Yes. Good, good. We want to solve for an angle. So I like my angle in the numerator because it does save you one step. It's not a big deal if you don't. Okay. Okay, but we're gonna solve for B. Okay, so I'm gonna put sine B. Oh, I'm not sine B over 12 inches is equal to, and I have to use the given angle pair, angle side pair. What is gonna go in my numerator?
Sine 42.
Absolutely, sine 42. What has to go in the denominator?
22.
22. The first step in solving this, you guys are gonna rock it. You know how to do this.
Looks like toilet.
Yes, you're gonna multiply by 12 on both sides. Okay, I'm gonna rewrite this step here because this is where students will start to question. So I want you to think about your questions. I'm gonna tell you that we need to remove the sign from the B. I need to separate them. We do that using opposite operations. Sine is an operation. Sine is an operation that takes an angle and gives you a ratio, a side ratio. We need an operation that takes a side ratio and gives an angle. What is that operation? You have used it before.
We have some differences.
We won't be able to use special triangles in this unit at all. Yes, because no right angles. It's an operation.
I want to say this. Oh wait, it's the 1 over.
It's not from the last unit, it's from unit 2.
Not.
Alex. Yes. Perfect. Good thinker, Alex. It's the inverse. The inverse is the opposite of sine. So I'm going to sine inverse both sides.
Well, do you take the 42 and divide by 2?
And that will separate the sine from the B, and I'm going to type that in my calculator.
So if we do it to one side, how will it take out? Will it take out the sign from the other side?
Yes. Not this one, but this one.
Why won't it take the one on?
Okay, so, class, let me do a little bit of a review problem with you from Math 1, okay? Just so you guys can understand it in this advanced setting. Okay, if I said 2x equals 4, how would you solve it? Divide by 2. And why are we dividing instead of adding or subtracting?
Get x.
Because multiplication and division are what kind of operations? They undo each other, right? They're opposite operations or inverse operations. Okay, how would you do this one? Subtract. Okay, the opposite of sine. So sine is something that takes an angle and gives you a ratio, right? The y over the r. The sine inverse is the exact opposite. It takes the ratio and gives you the angle. Here, do we know our angle?
No.
No. So we use the sine inverse to undo it. And I do it for this side to take this ratio and turn it into an angle. This is a ratio.
So does the inverse sign affect the right side of the equation?
Only the right side. The left side, it cancels out the sign. So I'm left with this. Let me show you. You have just B is equal to sine inverse of all of that. That's what I'm going to type in my calculator. Do you see it a little bit better now? Okay, I'm going to type it in my calculator so you can see what it looks like.
Shut up.
Okay, I'm sure my calculator is. Thank you. Ah, I just found
That
mine.
is not right.
Thank you. I just found mine. Okay, clear. So I'm gonna go sine inverse. I recommend using a calculator that has a fraction button. It eliminates errors. I'm gonna type in my 12, my sine 42.
There we go.
All calculators will put that parenthesis in there, I believe.
Now I
So
got
I'm gonna close it, go into my denominator, 22. And when I hit enter, I get my angle of 21.4 degrees.
Oh, you didn't round to the 0?
I should round, actually that 4 to a 0 because.
Why wouldn't you round the
Because we
that
have
before
to-
into, because the book says 21.41.
We have
Right,
no
the book says
decimal.
21.41, but, it didn't tell me what to do, so I will usually round to whatever is given. See how I have whole numbers? Whole
Oh,
numbers,
okay.
whole numbers, so I tend to follow, like we do in science. Hey,
Oh my god, that's
perfect! Oh, I got more than one. Nice. Super awesome, thank you. You want some?
I was and am are two different things. That's what she is.
Okay. So I'm gonna write that answer down. Now, you're always gonna get an acute angle. Anybody know why you're always gonna end up with an acute angle? Think about sine inverse. You guys did not like this. You did not like inverses in Unit 2.
What?
Do you remember when we were solving expressions with inverses? And I said sine inverse of 1/2. What was your answer? 2? It's an angle.
60 degrees.
Almost.
60 degrees.
30 degrees. It takes it and gives it back, okay? But now here's the hard one. You guys didn't like this one. You did well on the test because it was in your short-term memory. What's that one?
Not sure.
It's not 270.
Still negative.
Yes, Eric. It logged into your longer term memory, which is awesome.
You said it first.
Oh, you did, Alex? Yeah, good. You did so good, Alex. Okay,
Yeah, let's
so
go.
that's because sine inverse only gives you solutions between 0 and 90 and negative 90, and it'll never give you an obtuse angle. It's always going to be between 0 and 90 or 0 and negative 90. That's what causes the ambiguous case, which I will talk about next time, not today. Or I'll put in a video so you guys can see it. Okay, for now, I'm going to tell you that's our angle. It's going to work. I'm going to come back to it later and show you how we check it. Okay, but for now, that's all we're going to do. Okay, so that's our angle. You're going to use your angle to find your last angle. So let me write that. Or maybe we go. Step 3. Use A and B to solve for C. You do not need law of sines. What theorem am I thinking about?
Pythagorean.
Definitely not Pythagorean, because that's a right triangle theorem.
Whatever the 180.
The 181, good. You don't have to remember it, but for my notes, I like to write it down.
No.
Oh, the IAS.
IAS.
I just know
It
the-
says that angle C, I'm gonna put approximate because angle B is rounded, is equal to 180 degrees minus 42 degrees, which is your angle A, minus your angle B, which is approximately 21 degrees.
You'll get the magic number.
117 degrees.
117 degrees, absolutely.
I know, quick math.
That's good. I looked in the book too, because I didn't remember that one. I didn't memorize it. Yes, using the brain.
Walker.
Think smarter, not harder, right?
Yeah, efficiency is just clever labor.
Efficiency is key. Okay. Then you're going to use that angle and your given pair to find your last side.
So we don't have to, we're just going to use the regular ones instead of flipping it, right?
Yes, you're going to use the regular one for finding a side. Okay. Ask me. Ask me. I can't answer unless you ask.
Well, I guess we're at a state meeting.
Okay, so I am going to use the law of sines again. This time I want side C. So side C over sine of what? 117. I am going to use my approximate symbol because I rounded that 117. Okay, and I'm going to bring down my given angle side pair. Okay, and how do I get C by itself?
X plus sine of 117.
Divide by sign here.
Okay, and so I'm going to enter that in my calculator. And because I rounded, my answers might be slightly different. Okay, I will share with you that I'm going to show you guys this little tip here. Okay, see how I got 21 and not 21.4. Okay, so if I were finding angle C and I didn't want to get an exact value instead of an approximate, I would go my 180 minus my 42 minus my previous answer. See here how it says answer? So I hit the shift button and it will subtract and give me the exact value. That is the answer in your book for angle C. And so then I could go fraction 22 sine of that answer. I like this part of the calculator stuff. It might be confusing for some of you. But then I get 29.4, which is the answer in the book. Okay.
Yeah, I had like 29.2.
29.2?
3.
So, yeah, I'm going to use our rounded answer now. Because I used exact values instead of the rounded 117. So if I use the rounded 117, look what I get. See how they're slightly different?
Will we get one marked on it?
No.
We do either one.
I will give you credit for either one, because guess what? They both round to be what?
29.
29. Yes, Megan.
Oh, I was gonna say if ironic sisters numbers I got the 29.4.
Yes. Very good. So, and I used to do that all the time. Megan said she'd round to the 100. I used to actually always round all of them to the 1,000. And you're gonna see if you look at my old notes from previous years, I did to the 1,000th, and my answers were always the exact same as the textbook. So, I love that. So yeah, the more digits you keep after the decimal, the more it's gonna look like the book. But I don't care, I'm not that much of a stickler. Okay, so I'm gonna write down my answer. And that was 29.4, but I'm gonna round to 29 inches. Okay? So those are my final answers. I am gonna revisit this problem another day when I talk to you about the option for 2 solutions. This one only has 1. Okay? I'm gonna write that down. Final answer. C is 117 degrees. Little c is 29 inches. And side B is 20. Angle B is approximately 20. All right. What I want you guys to do, I know my card students have to get ready to leave. I want everybody else to work on number 7, 13, and if you have time, number 23. I will do one more example with those of you who stay so that you can see the no solution. It's really easy. Card students, I will. Absolutely. Yeah. I'm gonna put it in my in your group folder so I don't lose it. Oh, which group folder is this one? Yeah. Thank you. Oh no, someone kicked my thing. Darn it!